Audio Jungle.
So for us to better understand how this principle works, this is an example of how we use this method of analysis. For us to identify how many equations we can form in this circuit, so we count the number of nodes, 1, 2, and 3, then subtract it by 1 for us to know how many equations we will be able to form. So since these are 3, so 3 minus 1 will be 2, so 2 equations will be formed through this circuit. Then, tuloy-tuloy na. Ayan. So, first step is we identify the first equation node by node, and we will take node A first. So, at node A, so by KCL, we can know that or find out that the current passing through node A is PA over 2 kilo ohms plus VA minus VB over 2 kilo ohms, and is equal to 6 milliamperes plus 1 milliampere. So this equation has been formed because, as you can see, the current going inside node A or through node A is equal to that of which goes out, which is these two terms. And simplifying this equation, we can get VA all over 2 plus VA minus VB all over 2, and is equal to 7. Then further simplifying it, we get 2VA plus minus VB equal to 14. And this will be our equation 1. By nodal analysis, this is the equation that we formed at node A. Then for node B, we again form or perform Kirchhoff's current law. So by again analyzing what currents go in and out through the node, so we get VB, or the voltage at node B, divided by 2 kilo ohms plus VB minus VA over 2 kilo ohms, and is equal to 2 milliamperes minus 1 milliampere. Then simplifying this equation, we get VB over 2 plus VB minus VA over 2, and is equal to 1. And again, by analyzing how this can be simplified, we get 2 VB minus VA, and is equal to 2. And this will be our equation 2. Sorry na. Apply ko lang. Then, as you can see, we already have 2 equations which we have predicted earlier to be formed. And using these 2 equations, we can get the values of VA and VB. So analyzing this, then solving it simultaneously, we get VA is equal to 10 volts and VB to be equal to 6 volts. And this is our voltage or the voltages found at nodes A and nodes B.
Hello everyone, I'm here to discuss nodal analysis in AC form. So the idea about nodal analysis in AC form is the same about nodal analysis in DC form. We're going to use Kirchhoff's current law in solving, and we're going to assign some nodes. But first, there are three important ideas in solving in AC form. First, the two current sources must have the same trigonometric function. If it is cosine, the other one should be also cosine. If it is sine, the other one should be also sine. Since in the given circuit, the two current sources are both cosine, so there's no problem with that. Next, the two current sources should have the same positive amplitude. Since both of them have positive amplitude, there's no problem with that again. Last, both current sources should have the same angular frequency. The angular frequency in the first current source is 377, and the angular frequency in the another current source is 377. So there's no problem with that. So in the three ideas, there's no problem. So we can solve the circuit. So we must get the equivalent impedance of the inductor and the capacitor. In order to get the equivalent impedance of the inductor, we must use the formula JWL. And for the capacitor, we must use the formula 1 all over JWC. So for the inductor, J times the angular frequency, 377 radians per second, times 7.96 millihenries. And for the capacitor, 1 all over J 377 times 663 microfarads. Computing for the values will arrive in 3 J ohms. The other one, negative 4 J ohms. Now, we must transform 5 cosine 377t into its phasor form. It is equivalent into 5 angle 0 degrees ampere. And the other current source is equivalent to 2 angle 90 degrees ampere. Plugging all the values in the given circuit will arrive into this form. So next, we're going to assign the nodes. So I'm going to assign this node as node A, and this node as node B, and this one as the reference node. The number of equations will depend on the number of nodes minus 1. Since we have 3 nodes, we're going to have 3 minus 1 equations is equal to 2 equations. So first, we're going to calculate the current entering and leaving. So first, we're going to calculate the current entering and leaving in node A by using KCL. So at node A, VA all over 1 plus VA minus VB all over negative 4J plus VA minus VB all over 3J is equals to 5 angle 0 degrees. Simplifying the equation, we'll get dA plus 0.25 J dA minus dB minus 1 all over 3J dA minus dB is equal to 5 angle 0 degrees. Simplifying further, we'll get 1 minus 1 all over 12 J dA plus 1 all over 12 J dB is equal to 5 angle 0 degrees. And this will be our equation number 1 for the node A. Now, we're going to compute the current entering and leaving at node B. So at node B, applying KCL, we'll get VB all over 2 plus VB minus VA all over negative 4J plus VB minus VA all over 3J is equal to 2 angle 90 degrees. Simplifying the further equation, we'll get 0.5 VB plus 1 all over 4 J VB minus VA minus 1 all over 3 J VB minus VA is equal to 2 angle 90 degrees. And this will be our equation number 2.
Go.
Now that we got the two equations from our circuit, we can solve these two equations simultaneously. So by equating these two equations simultaneously, we'll get negative 1/2 plus 1 all over 8J VB is equal to negative 1 all over 6 minus 19 all over 12J. In this equation, we can now get the value of VB, which is equal to negative 22 all over 51 plus 52 all over 17J volts. By plugging VB into equation 1, we can get the value of VA, which is equal to 260 66 all over 51 plus 8 all over 17 J volts. Transforming VA and VB into time domain is equal to VA of t is equal to 5.24 cosine 377 t plus 5.16 degrees volts, and V of t is equal to 3.09 cosine 377 t plus 98.03 degrees volts. So here are the volts in node A passing to node A and the volt passing to node B.